Hello, and welcome to the webinar, What to Consider When It Comes to Your Aggregate Equipment Tire Maintenance, sponsored by Maxam Tire and hosted by OEM Off Highway. I'm Chris Favre, and I'm the editor for OEM Off Highway, and I'm happy to join you as the moderator for today's webinar. Before we get started, here are a few tips to get the best experience during today's webinar. On your screen, there should be a tool on the left-hand side of your screen for you to enter and submit questions. Please type in your questions throughout the webinar. We've set some time at the end for our expert to go through as many as we can. If you're having technical problems or issues, please fill it out in the Q&A box, and a technician will get in touch with you right away. There also is a box within the platform with some content from Maxam for you to look at. Today's webinar is being recorded and will be on demand within 24 hours afterward. You'll be able to find it through the link that was sent to you from registering or on the OEM Off Highway website. Now let me introduce today's expert, Jeremy Eds. Jeremy is the Director of National Sales and Solid OTR at Maxam Tire North America and is primarily responsible for the growth and strategy of national account and solid off-the-road business in North America. Jeremy is an accomplished sales and operations manager with more than 17 years of experience leading development of sales strategy in the tire industry. Prior to joining Maxam Tire, he held various field and management positions for almost 2 decades of his career in the off-the-road tire industry. Jeremy has a proven record of providing stellar customer support with his in-depth knowledge, along with extending long-term business relationships and driving business developments. Welcome, Jeremy, and thanks for joining us today.
Yeah, thanks for having me. Look forward to getting going here. So yeah, just to echo, we're going to get started today and talk a lot about air pressure, road conditions, things of that nature. Really, big piece on tire awareness. What to look for, air pressure wise, your haul roads, common tire failures, inspections, and then we'll go into a summary here toward the end. Lots of good information here, so love to take questions at the end, or you could message me or whatever, and if you decide this is something that you'd like to look at or need help with at your operation, we have an entire team across the U.S. and we'd love to come and sit down with you sometime. So we're going to go right into tire awareness, functions of tires, and their limits. So what does a tire do? What's the function of a tire? Really, the tire is what carries the load in any mining and quarry operation or landfill, whatever it may be. That's what's carrying load. So if you think of a loader, you pick up a load of rock or dirt, whatever it may be, coal, that once you pick that up, all that load is being transferred to your tires. So tires provide traction and braking. So if you have a tire with no traction left on it, you will slide. Makes dangerous operation, which makes your braking distance even longer, right? So control the direction of your travel. Without proper tire tread, you're going to slip and slide. So it's going to help with that traction, and and proper inflation is also a big key factor to that. Tires absorbed the shock from what you feel from the road, so they provide comfort, especially in a radial tire line or non-solid or non-bias. Most of the time, they can overcome some obstacles, and we'll see later on, and we'll talk about it. And some of you folks on here, could be production or maintenance managers, and as well as I do, a rock the size of a football or even the size of a baseball can destroy a tire. So how much can they carry? How fast can they travel? The heat, how much heat can they sustain? How much impact can they absorb? That's what we go out to sites. We do GPS studies. We do site evaluations, and in doing so, we're able to tell what that tire can do as far as heat, distance, load carrying capacity, things of that nature. But air pressure is the most important aspect of a tire. I like to tell people that air to a tire is like oil to an engine. You see a lot in Class 8 trucks where people today still go around and thump tires. You can't get your proper inflation by doing so. And I like to use the analogy, after you get done doing so, now go lay your hand on the hood or on the engine of that piece of equipment and tell me how much oil's in it. So air pressure is very important. Air pressure, it helps with the deflection of the tire. So deflection of the tire, meaning the squat or the sidewall that you see coming out. If that gets down, that leads into can lead to a catastrophic failure in that tire. Let's see, I'm trying to see that. Traction and braking. Once again, sometimes you hear off the road in soupy conditions and muddy conditions, lowering air pressure a little bit for more traction. But if you have too much inflation in those tires, you can have slipping. And once again, not having the proper tread depth can lead to that as well. Added durability. Once you're underinflated, you're more susceptible to punctures, overheating in your tires. Provides control. Once again, that goes back to the traction. Heat levels. So the lower the air pressure, you're going to really build up some heat, especially if in a loader situation where you're doing any kind of tramming or whatsoever. You'll definitely see some heat build up and can lead to premature tire failure. And absorption obviously helps with the ride. I visit locations often and we recommend tire pressure. And we see this a lot in loader application, even some rigid frame, but we put the right PSI, but a loader operator may come in and lower that down for a ride. So really that absorption, leans both ways. It's comfort and it's stability for the price you pay for the tire and taking that inflation into consideration. Overinflated versus underinflated. So 30% overinflated. So you're setting yourself up for impact brakes. So if you do see that rock that's the size of a baseball and you're underinflated, that can cause an impact brake. So it's like a rock hitting a rock at that point, right? So underinflating, you can see there a drop of 5% and a drop in 10%. Leads to major heat buildup, doing damage to the sidewalls, bead areas, even your flanges on your wheels, because your sidewall is actually deflecting over the flanges and puts that extra added stress on your wheel components as well. Cold tire versus hot tire. In the industry, we always recommend you can check a hot tire, but it's not going to give you an accurate reading. So if you're looking at a Class 8 truck, 11R22.5, Low Pro 22.5, and you set that at 100 PSI, and that truck's traveling, 100, 200 miles on a hot day, they can actually gain 35 PSI in air pressure. So if you check that, you're going to see that that's overinflated and you're going to drop it back down to 100. So when that tire cools, you're actually going to be 35 pounds low. So you always want to check your tires at a cold temperature. So during the morning or pre-trip, things of that nature, or you depend on the professionals, your tire dealer. Folks like us, we come out and do quarterly surveys with our dealers to make sure, and we look at everyone's tires, right? So we make sure that inflation is there and set to the right pressure. And when I say we look at everyone's tires, we want to be a business solution provider because we know that you've made an initial investment in another brand or whatever, and that's okay. We want you to get the money out of that tire. So we will continue to check those for you. So key component, just never check a hot tire and never let air out of a hot tire. Good inflation practices, hold accountability. I know in the industry right now, and I think it's getting a little bit better, but finding skilled operators. There's operators that are aging out, if you will. So you're having to get younger operators and having to train them, hold them accountable for checking their tires. Work with people that do like a little tire kicker at the end of the month or at the end of the year, who took care of their tires the most. They give them a little something at the end of the year, whatever. So make sure your valve caps are in place. That's your first line of defense. Off the road tires, it's a little more pressure, but if you can leave the core out and put that valve cap on there, that will actually stop the air from coming out of there. So having that valve cap is really a dust cover, because a piece of dust gets down in that valve core, you're going to have a leak there. So always make sure you have your valve caps. Good pressure gauges. I always recommend one that's calibratable, and then even have a master gauge. Rule of thumb is every time that you drop a pressure gauge, it could lose up to 2 pounds of pressure. So if you get one that's calibratable and have a master gauge to test up against that, you're good. You're having the right inflations. Cold inflation, once again, hot inflation. Never let air out of a hot tire. Don't check them because it could give you wrong readings. Always do it when it's cold. So we always ask, especially if you have a big fleet and it's a dealer or us coming in, when are trucks going to be parked, or when are loaders or whatever going to be parked where they can cool for 24 hours? When we look at even bigger haul trucks up to the 63-inch size, they actually even need a little more time to actually get cool in that. So you can see here incorrect inflation and what that does to the footprint. So on the left side there, we want that footprint, when we do these models at the plant, we want them to be almost like a perfect barrel. That means all of your tread face is actually touching the surface. So you can see if you're overinflated, you can see this in your personal car or whatever. If you have too much, that center of the tire wears out. So you can see in that footprint model right there where it's darker in color, that's really the only thing that's touching. The X-ray is actually picking up that other piece of tread, but it's not touching as the contact surface isn't there, right? So underinflated, so that brings all of your shoulder wear. So you can see in this third demonstration here where the center ribs aren't actually, it's not carrying the load, your sidewalls are, or your shoulders of the tires. So you want your inflation proper, because it helps with the load, speeds, whole 9 yards in the life of the tire. Failure to maintain proper air pressure. So excessive wear, as you've seen just in the previous slide, you can either wear out the center of the tire with too much pressure, not enough pressure, you're going to wear out the shoulders of the tire. Tire component separation. So when we see low inflation, you'll see what that can do here in some more slides coming up here, what that looks like and what it can do to a tire. But heat separations are big, and that's with air pressure as your first line of defense. But overloading, high speeds, things like that also you got to take into consideration. Rim slipping or indexing. You see that big time in loaders, especially with folks that will lower their air pressure. And it's not anything to do with maintenance or anything like that. They can set it, and then a loader operator just goes and unloads it. So when they're digging into the face, and we see it too with new operators as well, not letting the bucket do the work, they're just cramming the machine in there. But with low air pressure, you're going to get that indexing, which can tear the beads out of your tires, ultimately reducing your tire life and loss of productivity. So loader's going to go down. Hopefully you got a spare to keep production going, so while you're having the tires done. Benefits of correct air pressure. Maximum ground contact. Once again, we want that footprint to be an all contact surface and looking like that barrel. So that tire is supporting evenly that load. Optimum flexibility. You want to have that right to provide that flexibility in the sidewall, because having too much flexibility or not enough is bad on your beads and on that sidewall. It reduces heat. Once again, a low tire, especially a radial, in that sidewall will, every time it flex, it's building heat up. So once again, downtime reduction. Proper air maintenance, proper tire maintenance really helps production out a lot. All right, so a little more on air pressure and maintenance. Tire performance. Without proper PSI, overload tire, overload deflection, irregular wear, casing fatigue, tire failure. Know and check your air pressure. Quiz your folks that are doing it. Quiz your dealers. I encourage going behind your dealers or whoever it may be, even your current tire vendor. Stay on top of them. Just spot check some stuff after they've been there. Make sure that they're doing the right things. People get complacent. People skip things, get busy, and so stay on top of those folks as well. Road hazards, how to minimize them and extend tire life longevity. So spillage is a big thing, and avoiding spillage. Water is a huge piece. Curved roads and super elevation, we see that a lot at mine sites and quarries. So spillage, a lot of people will put sideboards or tailgates on haul trucks. But once again, when it's crunch time for production, or people aren't watching on second shift, overloading happens. If your curves are wrong and don't have any super elevation when you're hanging that curve, spillage is coming over off those sidewalls or sideboards onto the road. So the next truck or that truck comes back through, they're susceptible to damaging a tire. So what's wrong with this picture? The driver too heavy, box is too small, tires are too small. I think it's the load, right? And I have seen a real picture of this. If you Google, there's a picture in Australia where they put a rock. It kind of looked like this, but it broke the back axle completely in two on the truck. So water, especially in hard rock, acts as a lubricant. So especially if you have small shot rock at the bottom of a pit or spillage on the road and it's wet, those tires are wet, it'll cover. It acts like a razor blade. So that's why we want to clean up that spillage. Make sure motor graders are out. If you're slow, but motor graders to me is the most important piece of equipment on a job site. Because that's really protecting your equipment. Not only the tires, but that's all components, suspensions components. Deep water, hydrox. I was just in Canada at a location, and they were having some tire issues, and it was with all brands. And we went into a location, and the water was past my knees, and there was rocks, and the loader was loading off the face, tramming about 75 yards through that water, so he's spilling some stuff, and then putting it into the crusher. And I told the maintenance manager who was with me, I said, be ready for a call on this loader. And it was like 2 days later, both tires were destroyed by that time. 2 brand new Bridgestones. Here's a video I'm going to try to play here real quick. Not sure if it's going to let me. Yeah, it's not going to let me. This is an older video right here. You can go on YouTube and just look up machete versus water and tire. This gentleman hits that knife there with a hammer, and he can't do anything with it. So then he sprays some water on there, acts as a lubricant, and the knife goes right in just like butter. So I apologize, it's not pulling up for me. So what to check? Your floor, your bucket payloads, traffic patterns, cycle times, loader operator, dust control. The floor is the main thing in the pit. A good loader operator I like to see is when they're finished loading that truck and that truck pulls away, they're automatically sweeping the floor because they're going to go into the face, but they put that bucket down and they sweep the floor, make a couple of passes, then they get their load ready. I've seen some loader operators, where a truck will pull away, then the loader goes into the face, automatically gets a load and just hangs it up in the air. Meantime, there's rocks everywhere. And the next truck that backs in's running all over rocks. And the loader itself is now sitting on top of those rocks with this bucket in the air with all of that weight down on those front tires. So good loader operators always sweep the floor. I love to see that, so kudos to the good ones. Dust control is dust control a cause of production and safety issues? Absolutely. So without proper dust control, if you have a haul truck in front of you, one right in behind them, no water truck has been on site that day and putting water down, that's causing a line of vision where the operator can't see that's behind that truck following. So if there's a rock in the road, big rock, they don't know to try to miss it. They're going to hit it head on. So it's absolutely dust control is huge. Common tire failures and how to avoid them. Flat tires. Don't limp it. It'll cost you operation and downtime. If you have a tire that's extremely low in fatigue, let it sit there. That's what these big A2 off the road trucks are for, or service trucks are for. Let them come to you, because if you limp it, you can destroy a tire. That goes from the inner liner to the radial cables, sidewalls, beads. Just call it in and have someone change it. Zipper ruptures. You'll see that, and that's due to low air pressure. You'll see that. So improper mounting. Tire fitter needs to double inflate tire at time of mounting. So we like to air it up to a certain amount, decrease it a little bit, then air it, and then pump it, get it back on up. That way we call in the industry a GG ring is completely round around the wheel, and you're going to get a better ride. So run flat tires. So you can run one to destruction here, and that tire right there was ran for a long time underinflated. So you can see there's $11,000 loss here for improper mismatching on this left side here, and then a $26,000 loss right there. And I like to call the big rocks, for folks that don't know what you pay for tires, right, in an operation. And I doing safety training or training like this for operators, I like to get a rock off the site. It's fairly big, that has some black on it where you can see it's definitely ran over, and say, how much does this rock cost? This can be a $10,000 to a $30,000 rock, depending on the size of the tire. Zipper ruptures. You see this a lot in truck tires, and you see it in off the road, but a lot in retread plants in truck tires. They have a thing. If for those of you that have been through a retread plant, they have it's called a boom box. It's what they call it in the industry. So those tires go in there. They're inflated to see if they will zipper. And we do that in the industry to keep people safe, right? Because we want that tire to go off in that box rather than in a cage or on a truck and hurt someone. So when zippers happen, they happen really, really fast. One way you can hear them and know that it's kind of going to happen is if you're inflating, you always want to inflate in a gauge, or let your dealer do this. But if you're inflating and you hear it start popping a little bit, stand back, just let it go, get away from it. So that's what happens with the low PSI sometimes. Lots of things that can result in improper mounting. It can give you a bumpy ride, because it may have a low spot hanging down if they mounted it on the unit, so it's lower. They're not double inflating, not using enough or too much tire mounting lube. I've seen people use oil and solvents and stuff like that. So it's very, very important to maintain proper mounting. And that goes to your wheels too. Wheels are a big, big key component that our dealers and our tire experts and tire fitters should be looking at. And if you're doing your own tires, that's something you need to look at. And we can help with that too, as far as looking at wheels and helping out with that. But make sure that those flanges are no cracks, no bends, that your numbers are mounting up, because it's very dangerous if you have that and you walk by that and you see a bent flange ring. Get that stuff taken care of. And that's all improper mounting. And if you see something after someone has just mounted your tires, you see something, you need to have a conversation with them and make sure they have the proper training. Well, I got ahead of myself. So here's some of the things that you want to look at. So when I said the double inflation, this GG ring is on your car tires. It's on Class 8 tires and off the road. So that GG ring there needs to be flush all the way around the OD of the sidewall and the wheel. If you see that thing hopping or hiding, it's not mounted right. Once again, your flanges, your lock rings on your wheels. So all those components are key. And then every time that a tire fitter comes out and dismounts, they're going to dismount. They should be inspecting that wheel, cleaning the knurlings, cleaning all the gutters around the wheel, and inspecting all of that. And shouldn't just be popping on and popping off, putting back on, and I highly recommend Tire Life. It's a great tool, and it's a great cost saving tool for folks in this industry, because it actually helps save your wheels, actually helps save time as far as mounting and dismounting goes. So if you see a machine come OE that doesn't have Tire Life in it, you run that thing till it's time to change your tires. Most of the time, probably 90% of the time, because I came out of a service truck, you're going to have a heck of a time dismounting that tire. So I highly recommend Tire Life as well to protect your wheels. Daily pre and post trip inspections. Why they make the difference? It makes a difference, number one, for safety. If you're an operator, you're driving a really large machine, sometimes a 400-ton haul truck. Your responsibility is very big. So your tires and looking at those wheel components, I understand operators, aren't really checking PSI and looking at that stuff at a lot of places. But having that training and visually knowing if you can see a tire squatting, you see a wheel component bad, safety is number one. Because if that tire comes apart, a rule of thumb, a 29.5 R25, if it was laying down and the man was on top of it, it would blow him as high as the Empire State Building. So safety is number one. So, looking at valve stems, stuff like that, that's what we really, need to look at, the folks in the shops. If you see a valve stem, just make sure if you have extensions on it, they're tight. Wiggle your valve stems. If they're not tight, tighten them up. Let's, because that's very important. So our summary: air pressure, number one. It's air pressure is like oil to an engine. And hitting it or kicking it, it's not going to tell you the proper inflation. If you need to know proper inflation, we have a really nice website. We also have a free app that you can use that has our data sheets in it. And reach out to us if you say, hey, Jeremy, we have a mine and it's going to extend 2 miles or, something, and you're just unsure, let us come and help you figure it out. Let us, set the right standards in place to help your tires reach that longevity. Know the function of your tires. Once again, lean on your folks or, people in the right industry. You don't want to put an L5 loader tire in a L3 application. What I mean by that is you don't want to put a loader that's down in the pit with the bigger bucket up on a stockpile that's having to tram. That tire is going to overheat. So know your tires and where they go. An example was helping a customer out. Things were, trying to give them some advice. And what we ended up finding is he actually didn't know. He was an operations manager, but during the wintertime, they were actually moving equipment around. So they were actually doing that, putting an L5 and an L3 application, smoking tires. So void road hazards. I highly recommend training. We're here to help with that, especially with new drivers, stuff like that. I mean, because you think you're in a Tonka toy, right? Or they do. So they think they can just run over anything and it's not going to affect it. But, once again, it can be a $10,000 to $20,000, $30,000 rock, right? So proper training, again, we're here to help. We do safety training. We go out and, look at haul roads. We do super elevation training where we actually mount cameras on the front of rigid frame trucks. So if you're, watching how that tire flexes when you're coming into a curve and going out of that curve and recommending the proper super elevation in that curve. Pre and post trips. Make sure operators are aware of just what to look for. If they're not allowed to touch anything, stuff like that, tire wise, make sure that they know the basics. Is a valve cap missing? If not, write it down on your form and turn it into your maintenance personnel. Do you see something bent on a flange? Is there a huge cut in your sidewalls or a huge cut in the tread face? Make sure they're reporting that, because number one, that's safety. That's safety for your personnel, your customers, whole 9 yards. All right. Thank you for your time, and we'll open it up for any questions now.
Well, thanks, Jeremy, for the great presentation. Appreciate it. And yeah, as Jeremy indicated, it's time to start the Q&A session. Attendees, if you haven't submitted your question yet, please take a second to shoot those over to us using the Q&A box. We'll work to get through all the questions within the time we have. And Jeremy, I guess we'll start off with this question. Are there differences in building a loader tire versus haul truck tire?
Yeah, absolutely. Compounding in a haul truck tire, we can tweak a little more for higher heat, lower heat, more cut stability. So yeah, there's more technology goes into our haul truck tires, and then a loader tire, obviously reinforced sidewalls because you're getting into some shoddy spots. So if you're getting into rock and you don't have rock knockers or bucket wings on your buckets, you're going to be susceptible to your sidewall. So yeah, we reinforce those sidewalls on those tires with loaders.
Mm-hmm. And does it also play? Does the application and setting, how much of a role does that play, would you say, in when you're picking out these truck tires?
Well, I mean, application is key. Once again, putting an L5 or L4 in a application where it should be L3 is not good. That can lead you to premature tire failure, heat buildup, components, the whole 9 yards.
Mm-hmm. Yeah, and the people selecting the tires, do they generally have a pretty good idea of parameters, or is that something where an expert can come in and kind of guide them along and give them input if needed? Yeah,
I would say a lot of our dealers that we work with are very, very knowledgeable. And if they have questions, then they call us in, and that's where we come in. We do site severity inspections, looking at the haul roads, looking at the pits, stuff like that. We do nice report and we give that to our customers. It's theirs. We don't share it. And we use that as kind of like a second set of eyes and ears for them, showing them, what those conditions are.
Yeah, I figured there'd be some kind of added quality control because of your knowledge base, but I'm not surprised that the people you work with also have that knowledge base. It's more of a gut check, it sounds like.
Mm-hmm.
The next question we had is when should I select bias or radial when it comes to tires?
Well, bias now, what we're really seeing in the industry is some of your smaller loaders, stuff like that. Everybody's really moving to more of a radial. Your bias is going to be, let's say if you have you're removing overburden and just want something at a lower cost, your bias is a little bit lower of a cost that you can put in those situations, and you're really in an extreme environment. A radial tire is going to give you a better ride. You're more puncture resistant because of all the steel cables in there. But one thing that older operators, we're seeing it get out of, and manufacturers are really beefing up their sidewalls and loaders. But back in the day when bias was the only option, when a loader operator lifted his bucket up, it's really stiff, so they didn't get bucket sway. So with the radial, they get a little bit of movement, a little bit of extra movement. So, but yeah, that's really a long answer there. But it's it's a cheaper option. You can look at them, backhoes, stuff like that. So.
All right, and our next question is how do I know what speed the tire is capable of doing?
Well, that goes to our data books. So we have TMPH, which is ton miles per hour, and then we have TKPH, which is ton kilometers per hour, which is our standard, which comes from our test wheels in our factory, and other manufacturers have that as well. But folks want to push that. They want to push them past their capacity, right? So that's where we come in and do those GPS studies where we let a GPS run for 24 hours, gather that data, and look at that and see if it exceeds that TMPH. If it does, that's when we give recommendations on the speed. Okay, and inflation. We can bump up inflation a little bit to do some things, or slow something down. A lot of things like your carrier that carries the spatial, it goes at a creep, and that's what that is to do, and that's 3 to 5 miles an hour, and that's due to that overheating.
So. And I imagine there is a lot of testing and back and forth between you and other manufacturers as you're working through this to see as you're going along how much farther can you push the technology, right?
Sure. Yeah, because production wants to produce, right? And they want to produce as fast as they can. So we got to try to hang in there with them the best we can. So, and that's the tough part.
Yeah. I guess I'll close out with a question of my own. What do you kind of see as like the future for your tire maintenance? What do you think will be like a breakthrough, or what are you hoping will be a breakthrough in some of the technology that's being developed?
I've seen it in my years from just a little example as far as tracking tires. We did it on a clipboard and a piece of paper and a pencil with like a diagram of a truck or a loader on there, and then we'd have to go and key it in. So we've really reached technology now where we have Bluetooth tread depth gauges, we have Bluetooth air pressure gauges. So tires are. People are looking at different things. People are putting sensors in tires, and it's exciting. And especially when it makes us as tire people's job easier. We're able to report to our end users and our customers faster and show them what they need. So it's exciting.
Yeah, there's a lot of that digitalization, and being able to give all that information, and make you know help with the research side of things. So yeah, it does sound like it. We've been hearing it all over, and it's coming to the tire world as well. So very interesting.
Mhm.
Well, that was our last question. So that's going to do it for today. So we're going to bring our webinar to a close. I'd like to thank once again Jeremy for his insights and expertise here today. Appreciate taking the time to talk about this topic.
Yes, sir.
Attendees, you'll also be receiving an email from us soon with access to today's playback and presentation. But please also feel free to visit oemoffhighway.com to check out more on this topic and browse other topics in our bank of educational webinars. And thanks again to Jeremy and Maxam Tire for the presentation today. And thank you all for taking the time to join us. This concludes today's program. Thank you. Goodbye.